Hello, how's it going? We're at This Museum's Not Obsolete yet again. We've got Simon, the Prom 9, and Ash, and Connor's over there, and they're all making a project with flip dots today, flip dot displays. We're going to have a chat with them about it. Who wants to talk first?
So this all started off with my own project, because I got a bus display from an old 90s bus, which was 7 by, what was it, 84 or something? And then Ash got flippy flip dot running, but the controller had a problem. So I had to replace the LS244 chip. After some debugging with the scope, I managed to find that it was getting the inputs, but it wasn't outputting the outputs. So that was replaced and got that working. And this is all being quite recently over the Christmas period. Someone had pillaged the RS485 transceivers and the ballast resistors right there and there. So I soldered them on, didn't work. Resoldered them round, didn't work. Grabbed another board from my pile of broken circuit boards in my workshop, desoldered some resistors off there, soldered them on, and it finally worked, and we got a clock display. Here we have a flip dot display, which is a typical one you'd find in something like a bus, which is where they were most commonly used, but they're used on TV shows and whatnot through the decades. And basically what they are is tiny little electromagnets, so a bit like core memory, and of course they of course receive a reverse pulse. So what they do is they basically flip over these little plastic discs with magnets in, and then of course one side is usually black and then the other side has some sort of fluoro coating on it, usually a yellow. And then of course from that you can make text and images also. And it looks super cool when you do that. Cool, these are not penetrating through, which is what I wanted. That's not helpful, Connor. That's not helpful when I'm doing delicate precision stuff. The one thing to put on there now is the control boards, because Connor's running it for his own custom controller. But yeah, this is the one where I had to solder on the 485 chips, and that was the fix to this one. The other one I'm still pending on exactly what's wrong with it. But terminating these was a nightmare, because we don't have the proper tool for it. These little end connectors. Yeah, because we didn't have the connectors, we just improvised with some solder and electrical tape. And that seems to have done the job.
Don't worry, I got some longer ones that are going into the wood in the middle.
You're going to use a stroke level, you're just going to eyeball it.
Eyeball it.
Well, to be honest, we could eyeball it. We could lean it on that frame.
But then we're assuming that this rip cuts straight.
That was me.
Yeah, no, it's not straight.
Is it not? Well, I didn't have a ruler or anything. Where's the stool? I need the stool. Hello. Where's the stool? Is there a stool over there?
Did you just think someone's with your mum's side?
No? Oh. Right, we're going to need some serious upper body strength for a sec because I'm getting the stool.
You want to move that further my way.
Right, there we go. Yeah, I've got it. So we go down. Connor, you've got to go down. I mean, that's straight enough. That's straight enough. I'm going for it. Let's go for it. Oh, let's move it. Let's go this way.
Go that way then. Go on.
Right there. That looks good, don't it? Yeah. And then, like Connor, bring it down. Let's lean it onto this and let's just get it in. These are horrid, these screws. There we go, and then one more in the wood over up. Lovely. Okay, so this is cool. This looks good. Who's on next? What's the plan next? Is it Ash's turn? Ash, we need something. So we've got all of these wires dangling from it now.
Let's get it all hooked up.
What's your plan with this, guys? Let's get it wired in.
You've got your camera ready? Film me?
So it's going to run through the boot up process of the original Hanover controller.
And what's that doing? Just finding the ends of the display?
So it's learning how big the display is. As the controller doesn't actually know how big it is, it learns it every time it boots up, and then with some luck, we can have it controlled from here.
The program for this only addresses, it will address the X-axis as far as you want, but the Y-axis is only set up in the arrays for 8, which is currently something we're trying to figure out in the software to get that working, so it'll do the full 19. Luckily, we have some LED variants at home that are 19 down, so we're messing around with a similar setup at home to actually figure out the software side of this. At the moment, we're just giving it like one vertical and then a whole load of horizontal, and then just run something like glitter and it will do this, providing it's still, and then it will just update like this, so it's at least doing something that looks nice.
And is it just not recognised that end one yet?
No, we just need to increase the display length.
How do we do that?
In the code. Hang on.
Oh, let's have a look
Where's
at the code.
the command?
Oh, we're hacking now. You look like a tiny little child using a computer.
I know.
Green space hyphen R.
Cool. There we go. So what we'll do is, you see here, we've got the Y-axis there and the X-axis there.
Yeah.
We will up that to, say, 350.
Oh no, password. Get rid of that.
And then, oh, that's it just saying flippy flip dot, but badly.
Okay.
Fill. And see how far it goes. Oh, almost to the end. But yeah, that's basically the process of what we've got to do. Is just do that as a temporary, just running it for now until we get the software sorted. And also that dot, I'm going to need to climb up there and sort that dot out because that's not flipping.
Oh, we got one dead dot.
Yeah, it's just probably got missed. Probably just got touched when it's being put up there. That's an easy one to do. And then clock looks like this. Let's clear it. Clock. That's currently what the clock does. Clock looks like that because of the vertical addressing is still just 8 instead of 19 that we need to figure out exactly what it's doing in the code. We think it's something to do with the Node.js.
Yeah.
Yep. And it's fixed.
Oh, hey.
Hey! And then, just for funsies,
What is that one?
that's called glitter.
And that's just random noise. Basically.
Yeah, basically, yeah. It basically makes it look like a 70s mainframe, which I love. So basically what we got here is a controller. This one's from the 90s. This one's from 2007 or something. The other one's from the 90s. But it's basically a 90s design modernised. And what it does is it converts the 485 from the laptop, which we're donating to the museum, and then converts it to the serial data stream that these displays take, as well as dealing with all the power regulation and whatnot. And then of course it uses 485. I had to replace a transceiver bus, as mentioned previously in the video, mounted on some heat sinks because these do get warm, and they were mounted to the chassis in the original bus display. And then most of these would actually be 3 long, so we're actually running it a bit longer than they'd normally be done, but these controllers can support up to 4 panels. So the next step is basically getting it to do the arrays right to the displays so the resolution is correct.
And then we'll be able to play all sorts of wonderful things.
Yes, you'll be able to, yeah, you'll be able to have whatever you want up there.
Way good.
Cool, Simon.
Very nice.
I'll get the animations that loop continually. And today we are working on the flip dot display again, this time more the software side of it. On this particular case we're using Python to control it. So with that, because the original Flippy Flip Dot code has a lot of limitations, and it's running and compiled in a version of Node.js that uses an ancient version of Python, and you end up going down dependency hell. So it's basically being rewritten from scratch, which is going to take quite a while. But at the moment we've got Python, and we've got a test animation running on the display. Because the advantages of this project, it runs in parallel with one I'm doing personally at home to do as smart things. And so what we've got doing is the Python script is running on the Linux laptop over there, but I've just SSH'd into it because ergonomics are important. And for the moment, I've just been designing the bitmaps in MS Paint. So here's an example of one here. And then of course, I'm going to do a third one because I'm actually going to turn it into a 3-frame animation for this particular one. But when I get this set up, I want to make it so there's a few buttons on the website, so you click something and that will come up, or that would load as the default animation kind of thing. How we did the animation, and this is definitely one for easier to understand if you're more technical, is we've got Python. Let me open it in Nano because it's a bit easier to see. Oh, no, let's just open it in this because I've got to close the program. So what we have here is the def LMMC0 is one of the images that has been converted to a byte array. I used ChatGPT to help me create the image to byte array converter because it uses this weird format which I haven't seen before. This is just the usual imports of the various things you need. And if we scroll all the way down, we have the second byte array, which is here. And this is where it defines the next byte array. And then at the very bottom, we have... So we've got a few more definitions pointing at the serial port for the, not I2C, I've been doing I2C stuff lately, for the RS485. And here we've got the definition of the sign, which is an important one, resolution, because otherwise the program will error. It's not dynamic on the resolution front yet. And then here we have in the for is a for loop, which at the moment is running 1,000 times basically, and it basically calls the first frame, will sleep for 3 seconds, or doesn't sleep for 3 seconds anymore because I didn't need to stay on that long, and then after it's run that, it will run the next animation, and it's basically just pumping it out at the speed the 485 can pump it out because, well, it's slow enough that we don't need to worry about it going at video frame rate. You can get those particular panels to do video, but you need to basically build a custom controller, which is what our Scottish friend was doing when he was here last time. So the end goal with this is to get it so it's basically, it'll be this laptop under here. This is the laptop I'm using for development of this project. But it'll be this laptop under here will be running this code. And the idea is to have a basic web front that guests can interact with and do custom things on the display. But things like this will be selectable as animations and whatnot. And yeah, people will put things they're not supposed to on the display, but that's half the fun of it. And it'll just be fun. It'll be another little fun interactable thing. And you know, a lot of people never get to play with these because you only ever see them in buses, and they're getting rarer and rarer these days as the buses which house them get scrapped. And there are companies that still make flip dots and whatnot for like specialist bespoke displays and art pieces. There's a very famous one in a Nike store in Paris, but it's bespoke and the companies don't have the prices on their website, which usually means if you have to ask, you can't afford it. So this is basically where we're at with the flip dot display. And of course, there will be more development to come. So just keep checking back, an eye on the subscription box. And thanks for watching. And also visit the museum to see it in person.